Welcome viewers to another video of my channel. Today we will start with the lecture 4 of module Fundamental of Software Engineering. In this lecture, we will learn about responsible software engineering, coding rules, product standards, threat modeling, and software development lifecycle. Let us begin with some pointers which will help us in transforming our engineering approach towards responsible software development. We as engineers should follow certain principles of software ethics in beginning of the foundation, that is design and development and architecture. The UX should be laid such that it is inclusive to human race and diversity. The security of user sensitive data should be at most priority. While development, it is the duty of an engineer to deliver a sustainable product contributing toward green environment. When it comes to modern technologies such as AI, the system should be tested iteratively in order to mitigate the biases in algorithms, model, and data. The delivery of the product should be done in the way where it should follow all the social guidelines and contribute toward the healthy social impacts. Coming toward the code and infrastructure, developers should follow coding rules to deliver the quality product. The transparent collaboration and communication between developers, stakeholders, and users help everyone to be on same page, and utmost priority to be given to the laws and regulation of the region the software is developed for and complying towards it. Now let us see how we as developers shape a product by following coding rules. Coding is all about English instructions in form of programming. So using clear and descriptive names of variable and constants make the code understandable. Following the modular approach while writing methods and components make the code structured, readable and reusable. Commenting over each piece of code helps other coder to understand the code. We should avoid the language keywords such as class, object as variable name. In order to write clean code, we have to do consistent formatting and avoid nested coding in our code. By leveraging built-in functions and libraries, we can reuse the code and make our code lightweight. By introducing error handling and validations, we can make our code robust and bug-free. The ultimate mantra is do not repeat yourself. There are set of standards we have to follow while delivering the piece of code. In order to deliver secure code, OWASP and other organizations have piled up list of security guidelines which we should follow. There are certain usability and user experience standards that are made to provide intuitive and inclusive user-centric products. The most important standard is SDLC and QA standards, as they make sure the developer ship the software in most compliant and standardized manner. There are some standards that says the shipped product or software should have proper documentations, reporting, maintenance and support standards to make the software up to date. Some standard says in order to keep the software secure and compliant, they should be regularly updated with latest version and follow FOSS or OSS standards if open source software and libraries are used. Let us move to the most critical topic, that is threat modeling. Before developing any software, the group of security and development engineers sits and find the potential security threats to their proposed architecture and work on the mitigation strategies to reduce or eliminate those security risks. Threat modeling has sets of principles which includes identification of the critical modules which need threat modeling, then listing down potential threats for each module, and then evaluate their likelihood and impact. And at the last, defining the mitigation strategies. The threat modeling is not a one-time job. At each version update of a product, the threat modeling is the must process. Now we jump to last topic of this lecture, that is SDLC, software development lifecycle. That is the standard process of planning, design, development, testing, deployment, and maintenance. Let us understand each phase one by one. Planning phase focuses on the definition of scope, resources, and timeline of the project. In this phase, product group work on the requirement gathering, project planning, risk assessment, and feasibility analysis. Once the planning phase is done, the group of architects and senior engineers create a blueprint of the project, which includes high-level architecture, detailed component design, DB schemas, and US mockups. This phase is called design phase. Once the design is done, the implementation of each module design is converted to epic, backlog, and story. And now the junior developers and developers pick up these assignments and convert the design into piece of code. And thus this phase is called development phase. Parallelly, in design phase, test lead has already proposed a test plan for which testing team ensures the software work as intended and meet the requirement, and thus it is called testing phase. Their activity includes functional testing, performance testing, and security testing. And the developer has to fix the identified bugs. In most of the product teams, the development and testing happens simultaneously. Once the testing team approves the piece of code, it goes to the deployment phase, where it gets prepared for the production environment. In most of the teams, CI/CD is followed for continuous delivery of a piece of code. And at the last stage, the customer-facing team makes sure the assistance and maintenance to the newly released version and monitor them. Thank you for taking this lecture. Let us meet in the next lecture. Till then, happy coding. And do not forget to like, share, and subscribe, and follow me on social handles.